Okay, here is our extra review, getting ready for the quiz on hyperbolas and parabolas. Let's make this a little bit larger and ready to go. Okay, so this just walks through a sampling of the kinds of problems you should expect to see on the upcoming quiz. Give me just one moment. So first one, I give you the graph, you give me back the equation. First one, hyperbola, it is vertical. So that means you have a center. You have two vertices. You also are going to have foci, but let's figure out, we got to figure out what A and B, and we have to figure out the equation. So being vertical, I know that this is going to look like y minus k squared over b squared minus x minus h squared over a squared equal 1. So I just need hk, a, and b. It looks like this is centered at -3, 2. So that's hk. It looks like that the distance from the center to the vertex is 2. So I know that b is equal to 2. I just need to figure out what a is. If I construct this box, it comes right here. So I go down till I get the intersection. Over here till I get the intersection, and down and so forth. You can see that the distance along the horizontal is what, 1, 2, 3, 4. So a is equal to 4. This equation is simply y minus 2 squared over 4 minus x plus 3 squared over 16 equal 1. Next one, similarly, it is a hyperbola. This one is horizontal. So this will look like x minus h squared over a squared minus y minus k squared over b squared equal 1. It looks like in this case, hk is -4, -1. So centered at -4, -1. I can tell that a is 1, 2, 3. So a is equal to 3, and if I construct this box, I will see that b is equal to 2. So this equation is simply x plus 4 squared over 9 minus y plus 1 squared over 4 equal 1. Continuing on, I have a couple of parabolas. This parabola is of the form y minus k equal 1 over 4p x minus h squared. It points down. I know that p is going to be negative in this case. So what is my vertex? So my vertex is -1, 5. So -1, 5. And it looks like the distance from the vertex to the focus is 1. So I know that p is equal to -1. This equation is y minus 5 equal. If p is -1, that translates to -1/4 x plus 1 squared. Next one, parabola. This is horizontal. It will be of the form x minus h is 1 over 4p y minus k squared. Vertex is -2, 1. I know in this case p will also be negative because this opens to the left. The distance from, now if you look at it, don't get too overly concerned, these are just fractions. So if the vertex is at -2, so I see -2 is where the vertex is, and the directrix is -3/2. That's -1.5. What's the distance from -1.5 to -2? That distance is 1/2. So p is going to be -1/2. So this means that x minus 1 equal 1 over 4 times -1/2 times y minus 1 squared Simplify that just a bit, and you will get x minus 1 equal negative 1/2 y minus 1 squared. Completing the square. People struggle with this last time. You're going to have to really get solid with this. This stays with us for the remainder of our conic section. First thing I want to do, I want to get all the constants on one side and then work with my x's and y's on the left. Okay, so I'm going to write this as 4x squared plus 8x minus 5y squared plus 30y equal, if I bring the 41 to the other side, I get 61. Now I have to complete the square in x and y. In order to do that, I have to factor whatever is in front of the quadratic term. So this will give me 4 times x squared plus 2x, and I'm going to leave some space. Factor out a negative 5, y squared. So negative 5 times y squared is negative 5y squared. What do I multiply negative 5 by to get positive 30y? That's going to be negative 6y. Okay. Leave some space there. Equal 61. Now, what must I do to complete the square? I've got to add 1 squared here. I have to add 3 squared here. So what did I do in effect? So what you see here is that's the same as adding 4. So I must add 4 on the right. And then what I see here, this is the same as 3 squared is 9. 9 times 5 is 45. That is subtracting 45. So if I subtract 45 on the left, I must also subtract 45 on the right. So when I do that, so that's 65 minus 45, that's 20. So I get, as my factorization here, 4. And I have x plus 1 squared minus 5. Y minus 3 squared equal 20. If that's a hyperbola, I want it to be equal to 1. Divide everything by 20. And you end up with x plus 1 squared. 20 divided by 4 is 5. Minus 25 divided by 5 is 4. Y minus 3 squared over 4 equal 1. That is a horizontal hyperbola. Next is completing the square on a parabola. When I look at this one, the x is squared. So I need this to look like y minus k equal 1 over 4p x minus h squared. So I'm going to write this as y minus 17 equal 2 x squared minus 6x, and I'm going to complete the square. So in order to complete the square here, it looks like I need to add 3 squared. Okay, so if I add 3 squared over here, that's 9. 9 times 2, that is adding 18. If I add 18 to the right, I must add 18 to the left. So this is y plus 1 equal 2 x minus 3 squared. And that is our parabola. That is a vertical parabola opening upward. Complete the square to get this hyperbola in standard form. So I'm going to have negative 4x squared minus 16x plus 20y squared plus 20y equal 31. I need to factor what's in front of every quadratic. So negative 4x squared plus 4y, leave some space, plus 20 y squared plus y equal 31. Now to complete the square, I need to add 2 squared, and I need to add 1/2 squared. So what did I really do? So this is 2 squared is 4. 4 times negative 4 is negative 16. This is subtracting 16. Look at the next term. What is 1/2 squared? 1/2 squared is 1/4. What is 1/4 of 20? That is 5. If I'm adding 5 on the left, I must also add 5 on the right. So this is 36 minus 16. That is 20. So I get negative 4 x plus 2 squared plus 20 y plus 1/2 squared equal 20. I'm going to divide everything by 20. And that's when I come up with, this is negative x plus 2 squared. 20 divided by 4 is 5. Plus y plus 1/2 squared equal 1. You can leave it like that, or typically we tended to write the positive term first. So either of these would be a perfectly fine answer. Complete the square again. This is a parabola. It's going to be of the form, since the y is squared, it's going to be x minus h is 1 over 4p y minus k squared. So this is x minus 5 equal 5 y squared plus 10y. X minus 5 equal, factor out the 5, y squared plus 2y. And now what do I need to do to complete the square? I need to add 1 squared. So that's the same as adding 5. So I need to add 5 to the left as well. My answer is x equal, and this is 5 y plus 1 squared. Next problem. These are all graphing problems. So this first one is graphing a hyperbola. I need to find the center, the vertices, the foci, and the asymptotes. Center is 3, negative 1. Let me start my calculator here. The vertices. So, okay, I made a mistake, so I'm going to back up here real quick and redo this graph. So center is at 3, negative 1, 2, 1, 2, 3, negative 1. There is my center. A is equal to 2. B is equal to 1. So I can see if I draw this rectangle here, that tells me how to draw the asymptotes. They start from the center and they radiate to every corner of that rectangle. This is a horizontal hyperbola, so it's going to look like this. So I've got the center, I have the vertices, all I need are the foci. So the vertices here you can see are going to be at 5, negative 1, and 1, negative 1. Focal length, remember that a squared plus b squared equals c squared. So in this case, c squared is equal to 4 plus 1, which is 5. So c is the square root of 5. Okay, so square root of 5 is a number slightly bigger than 2. Okay, so that means that if I go slightly more than 2 away, I'm going to find the foci. So somewhere right in here are going to be the 2 focal points. And what precisely are those points? Those are going to be the points. If I start from the center, it's going to be 3 plus the square root of 5, negative 1, and 3 minus the square root of 5, negative 1. Those are the 2 focal points. Equation of the asymptotes. You can always just get this straight from looking at the original equation. Okay, it's got to be y minus k equal plus or minus b over a, x minus h. Now there is no computation that goes on here. If you know this, you're going to get this problem right. Don't know it, you're going to miss it. So look at the original problem, y plus 1. Y plus 1 equal plus or minus, what's b over a? That's going to be 1/2. And then x minus h is just x minus 3. This is a line. If you see any squared terms in there, you don't have a line. So this is the equation of the 2 asymptote lines. Let's look at the next one. This is graphing a parabola. This is a parabola that's going to open down. Okay, so if I look at it, where's the vertex? The vertex is negative 2, 0 because it's of the form y minus k equal 1 over 4p x minus h squared. Axis of symmetry. So if the vertex is at negative 2, 0, that's right here. The axis of symmetry is this line that you see. That's the line x equal negative 2. How do I find the focus? You set 1 over 4p equal negative 1 over 8. That tells you that p is equal to negative 2 to make that a true statement. So that means if I go up 2, that's where I find my directrix. If I go down 2, that's where I find my focus. And that's what this parabola looks like. So the directrix is the line y equal 2. Okay? And the focus point is going to be negative 2, negative 2. Continuing our graphs, hyperbola. This is a vertical hyperbola. The center is at negative 5, 1. I know that A is equal to 3, B is equal to 2. So negative 5, 1 is right here. And to find the vertices, so that means I'm going to go up 2, down 2, and then to the left and right 3, 1, 2, 3, 1, 2, 3. So when I complete this box, that helps me draw the asymptotes. And since this is vertical, this will be a vertex right here. I'll have another one here. So these vertices are at negative 5, 3, and negative 5, negative 1. Focal length, c squared, is equal to a squared plus b squared. That is going to be 13. So c is equal to square root of 13. That's a number. That number is between 3 and 4. So it tells me if I go up 1, 2, 3, somewhere in here, that's going to be a focus point. Go down 1, 2, 3, somewhere in here. That will also be a focus point. Those points are going to be negative 5 and 1 plus square root of 13. Negative 5, 1 minus square root of 13. Those are the two focal points. Equation of the asymptotes, y minus 1 equal plus or minus b over a. That's 2/3 x plus 5. Okay. Parabola. This is a parabola that opens up. So the vertex is going to be at 1, 2. And that means that the axis of symmetry is this vertical line you see right here at x equal 1. The focus, if I look at 1 over 4p equal 1 over 12, that tells me that p is equal to 3. So if this opens up, then 1, 2, 3, that's the focus at 0, the focus is at 1, 5. And then the directrix, 1, 2, 3, right here, is y equal negative 1. And the graph of this guy is like such. Last few problems. Give the equation of the two different hyperbolas centered at negative 3, 2. Okay, let's take a look. There might be a little bit of blip in the continuity of this recording, but take a look at the next problems where I give you a description and I'm asking you to give me the equation. Now this one I'm just throwing a wrinkle to make sure you're solid. Give the equation of the two different hyperbolas. We've not done this before. Centered at negative 3, 2. So 1, 2, 3, 1, 2. Okay, with a conjugate axis of length 4 and a transverse of length 5. So the only thing I'm not telling you which one's vertical, which one is horizontal. So what it means is I could have, if the conjugate is of length 4, transverse of length 5, it means this could be talking about a vertical or a horizontal. So let's just say, let's do the first case. Let's do the case of a horizontal. Okay. So if I do a horizontal, that means that the horizontal is my transverse. So transverse of length 5, 1, 2, 2.5. So right here, 1, 2.5. Okay, so that's what the horizontal is going to look like. And then if you go up 2, you got this. So that tells me for the horizontal, I'm going to have A equal 2.5, B is equal to 2. So that is going to be what, x plus 3 squared over 5/2 squared minus y minus 2 squared over 4 equal 1. Now the next case will be, can I construct a vertical hyperbola that meets these same criteria? So how can I do that vertically? So same center at -3, 2, 1, 2, 3, 1, 2. If it were vertical, then up and down would be my transverse. Transverse of length 5, 1, 2.5, 1, 2.5. That's this hyperbola you see going on right here, 1, 2. So that's telling me that A is equal to 2 and B is equal to 2.5. So that is going to be, with the vertical, y minus 2 squared over 5/2 squared minus x plus 3 squared over 4 equal 1. Okay, so just making sure you know the terminology between conjugate and transverse. Give the equation of the parabola with a vertex of -1, -1 and a focus of -1, 1. Vertex -1, -1 is right here. Focus of -1, 1. So that's the focus, that's the vertex. This parabola opens up, okay, and it tells me that P is equal to 2. So this is y minus k equal 1 over 4p x minus h squared. So in this case, it's going to be y plus 1 equal 1 over 4p is 1/8 x plus 1 squared. Give the equation of the hyperbola centered at 2, -4. That's right here. With a vertex at 2, -2. Okay, if that's a vertex, I know we're talking about a vertical hyperbola at this point. And a focus at 2, -1. Okay, right here is the focus. Okay, so I know this thing is centered at what? 2, -4 is my center. I can tell by looking at this that B is equal to 2. That's the distance from the center to the vertex. And now I also know that from the center to the focus, that's C. C is equal to 3. I don't know A, but I know that C squared equal A squared plus B squared, so C squared minus B squared equal A squared. Therefore, A squared is equal to 9 minus 4, which is 5. A is equal to square root of 5. Okay. So the equation for this, it's a vertical, so it's going to be y plus 4 squared over b squared minus x minus 2 squared over a squared equal 1. Give the equation of the parabola with a focus of -5, 5. -5, 5. That's a focus. And a directrix at y equal -3. 1, 2, 3. So that's my directrix. Okay. So if this is a focus and I've got a directrix, halfway between here is going to be where the vertex is. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. That has to be the vertex. This guy has to open upward. Vertex is -5, so the vertex is -5, 1. And in this case, P is going to be equal to 4. So this is y minus k equal 1 over 4p x minus h squared. So y minus 1 equal p is 4, so this is 1/16 x plus 5 squared. Number 15, give the equation of the horizontal parabola with a vertex of 0, 2, and a leading coefficient of the quadratic term being 1. vertex 0, 2. Okay, right here. It's horizontal. That means it's going to open either left or right. But the leading coefficient is 1. Okay, so if it's horizontal, it has to be of the form x minus h equal 1 over 4p y minus k squared. What's the quadratic term here? The quadratic term is going to be y squared. The coefficient of y squared is going to be equal to 1. So 1 over 4p is just going to equal 1. Okay, so this tells me that this is going to be, h is what, 0? So x minus 0 is equal to 1. And this is going to be what, y. Okay guys, there's a little bit of a problem with this one. Found it out in working. In order to make this work, these are vertices, okay, instead of foci. So vertices at negative 4, 4 and 6, 4, conjugate axis of 12. So at negative 4, 4 and 6, 4, 1, 2, 3, 4, 5, that means that A is equal to 5. So in this case, I know that A is equal to 5. The conjugate axis is 12. That means it goes up 6, down 6. B is equal to 6. And I know this is centered at, what's the center between negative 4, 4 and 6, 4? That's going to be at 1, 4. So this is going to be a horizontal. So it's x minus 1 squared over 25 minus y minus 6 squared over 36 equal 1. Okay, that's it, guys.